does awaken, it may howl and heave with a power that has never been seen before. It has been 640,000 years since the beast last awoke roaring. 1,000 cubic kilometers of ash and lava were expelled during the supervolcanic eruption, which is 8,000 times more than Mount St. Helens emitted in 1980. The Yellowstone eruption area fell in on itself, leaving a 1,500 square mile buried huge crater, or caldera. The famous geysers, hot springs, fumaroles, and mud pots in the park are still heated by the magmatic energy that drove that eruption and two others that occurred over 2.1 million years ago. Now, officials at the Yellowstone National Park have discovered that a sizable piece of magma has begun to pulse. People are currently wondering whether or not this ticking time bomb will burst. Could it erupt within our lifetimes if it does? And why is a Chicago-sized portion of Yellowstone pulsing? Join us as we explore how Yellowstone National Park officials just detected a massive chunk of magma that has started pulsating. Titanic forces drive some 10,000 geothermal features deep beneath Yellowstone National Park, the animal and woodland preserve situated on a vast stretch that runs through the states of Wyoming, Idaho, and Montana. The Earth's surface has been rising and falling as a result of those forces of heat and pressure, much like the irregular breathing of a large sleeping animal. The volcano itself is actually located in northwestern Wyoming, which is where the bulk of Yellowstone is situated. An area of molten and semi-molten rock known as magma is a hot region beneath the Yellowstone supervolcano. The ground swells as magma flows into a magma chamber or reservoir that is located 6 to 10 kilometers, 4 to 6 miles under the park, and the ground collapses as the magma starts to harden and cool. Volcanologists who have been monitoring this activity since 1923 estimate that between 2004 and 2009, the ground rose by around 25 centimeters, 9.8 inches, but in 2010, the ground started to sink. Many scientists are speculating about the possibility of an impending Yellowstone eruption due to the period of gradual, continuous growth. Concerns have been raised regarding the potential intensity of the eruption if it occurs. The Precambrian period encompasses the majority of Earth's history from the planet's genesis 4.6 billion years ago to around 541 million years ago. Northern Yellowstone and the adjacent Teton, Beartooth, Wind River, and Gros Ventre mountain ranges are home to rocks that are this old. The western United States once had oceans, sand dunes, tidal flats, and huge plains throughout the Precambrian and the following Paleozoic and Mesozoic eras, 541 to 66 million years ago. The Rocky Mountains were created by mountain-building processes towards the end of the Mesozoic and the beginning of the Cenozoic. The Yellowstone region was formed by massive mountain-building, volcanism, faulting, and glaciation during the Cenozoic era, about the last 66 million years of Earth's history. On the north and east edges of the park, the Absaroka Range was created around 50 million years ago as a result of several volcanic eruptions. The current Yellowstone volcano is unrelated to this period of volcanism. The enormous swathes of today's West started to separate along an east-west axis about 30 million years ago. Around 17 million years ago, this continual stretching process accelerated and produced the contemporary basin and range topography along north-south valleys and north-south mountain ranges, which is typical of much of the West, including the Yellowstone region. An active phase of volcanism began close to the borders of modern-day Nevada, Oregon, and Idaho around 16.5 million years ago. Volcanic eruptions that followed may be seen moving from southern Idaho to Yellowstone. The North American plate slid over a shallow body of magma in a southwesterly direction, forming a 500-mile path of more than 100 calderas. The Yellowstone region was transported nearer to the shallow magma body by the shifting of the North American plate about 2.1 million years ago. Volcanism like this is still what drives Yellowstone today. In the broader Yellowstone region, magma, molten rock from below the Earth's crust, is present near the surface. The mantle's thermal convection is the cause of this small mass of magma. Rocks in the crust are melted by magma plumes as they rise through the mantle, forming reservoirs of partially molten, partially solid rock. Mantle plumes cause hotspot volcanism by transferring heat from the mantle's depths to the crust. As tectonic plates move over hot regions, a trail of volcanic activity is left in their wake. The volcanic hot point that currently lies beneath the broader Yellowstone area left a swathe of volcanic deposits across Idaho's Snake River Plain when the North American plate migrated west during the past 16.5 million years. Rocks in the crust have melted due to the heat from the mantle plume, forming two magma chambers of partially molten, partially solid rock close to Yellowstone's surface. A portion of the crust above the shallowest magma chamber expanded and rose as a result of this heat. Increased earthquake activity was seen along freshly created faults as a result of stress on the crustal layer above. These faults eventually reached the magma chamber where magma began to seep through the fissures. Magma escaping the chamber relieved pressure, which also allowed volcanic gases to escape and explode violently in a large volcanic eruption. Large amounts of volcanic ash and gas were released into the atmosphere by the eruption, which also caused pyroclastic flows, rapid, extremely hot debris flows over the surrounding terrain. The land above the subsurface magma chamber sank as it emptied, forming the first of Yellowstone's three calderas. One of the greatest volcanic eruptions known to man, it covered 5,790 square miles of land, reaching as far as Missouri 2.1 million years ago. According to estimates, the entire amount of volcanic debris spewed was 8,000 times greater than that of the 1980 eruption of Mount St. Helens in Washington, which killed 56 people and thousands of animals and charred hundreds of square kilometers of land in Washington and Oregon. Around 1.3 million years ago, a second sizable, albeit smaller, volcanic eruption took place within the first caldera's western margin. The current Yellowstone caldera, which is 30 by 45 miles in size, was produced by the third and most recent major volcanic eruption 640,000 years ago. Since then, there have been 80 minor eruptions, and one of these produced what is now the west thumb of Yellowstone Lake about 174,000 years ago. The caldera floor and surrounding terrain were partially filled by enormous lava flows of viscous, rhyolitic lava during and after these explosive eruptions, as well as by less substantial basalt lava flow. The Pitchstone Rhyolite flow, located in the southwest of Yellowstone National Park, is the youngest of these lava flows at 70,000 years old. The majority of the continental United States was blanketed in large volumes of volcanic ash, gas, magma, and other volcanic debris from each of the prior eruptions. There have been some materials discovered as far away as Louisiana. Following each of these eruptions, the Yellowstone supervolcano fell in on itself, engulfing the surrounding terrain, including all of the trees, mountains, and other features. Calderas are the depressions created by this occurrence. In actuality, the Yellowstone caldera and Yellowstone supervolcano share the same name. In Yellowstone, a caldera-forming eruption would pose a huge natural hazard. Within the Yellowstone caldera, pressure from the shallow magma body has created two resurgent domes since the last of three eruptions that established the caldera. Sour Creek Dome and Mallard Lake Dome may both have magma as close to 3 to 8 miles and 8 to 12 miles respectively beneath them. Both domes experience uplift and subsidence as the amount of magma or hydrothermal fluids changes beneath them. The entire caldera floor also rises or falls, though not to the same extent as the two domes. The caldera floor has been tilted toward the south over the last century as a result of net inflation. As a result, Yellowstone Lake's southern sides have sunk, causing trees to now stand in water, and Fishing Bridge at the lake's northern end has risen into a sandy beach. The 50 kilometers, 30 miles wide, and 70 kilometers, 45 miles long Yellowstone caldera itself contains some remnants of the most recent eruption. In a region known as the Lava Creek Tuff, one can still observe the thick volcanic debris that was left over after the eruption. The remnant of the enormous volcanic eruption, which occurred 640,000 years ago, is a bubbling caldera in northwest Wyoming in the heart of Yellowstone National Park. The 3,472 square mile park surrounding the caldera is home to a geological paradise of bubbling pools and springing geysers, all of which are fueled by magma and extremely hot fluids that are churning in the rock below the surface. More than 500 hydrothermal features can be seen in one of these locations, the Norris Geyser Basin to the northwest of the caldera. These unpredictable geysers and pools frequently alter from day to day, but a much more significant metamorphosis has also been going on. For more than 20 years, a region concentrated around the basin has been erupting and contracting by several inches in irregular bursts. It is challenging to determine the precise origins of any given movement in a volcanically active area like Yellowstone. However, a recent scientific study might shed light on why this area of land has been inhaling and exhaling. Research geologist at the Cascades Volcano Observatory of the U.S. Geological Survey, Daniel Jurisian, asserts that Norris has most likely been a center of deformation for a very long time. In order to estimate what might have happened beneath Norris Geyser Basin's surface based on the changes above, researchers examined decades' worth of satellite-based radar and GPS data. When a magma body intruded beneath Norris in the late 1990s, fluids trapped inside of it erupted out and moved through the rocky maze above them. The ground would inflate as the fluids became trapped and pressure built up. As the fluids were allowed to escape to other locations, the ground would deflate. Today, magma-derived fluids might be found just a mile or two below the surface of the Earth. To be clear, the new research does not suggest that the supervolcano which last erupted 640,000 years ago and formed the caldera of Yellowstone is any more likely to explode now. The tallest active geyser in the world, Steamboat Geyser in the park, has instead been erupting at a record-breaking rate since March 2018. These geologic movements may help to explain why. Researchers also hypothesize that there may be a marginally higher risk of hydrothermal explosions occurring in the basin as a result of the changes below Norris. The geology of Yellowstone is intricate and secretive, and underground explorations are especially difficult. Researchers do, however, concur that the rising and sinking ground can be explained by the injection of a sizable mass of magma and the fluids that escaped during the eruption. The scientist in charge at the Yellowstone Volcano Observatory of the U.S. Geological Survey, Michael Poland, who wasn't involved in the new research, states that we're only just beginning to understand just how dynamic Norris Geyser Basin is. In addition to the unexpected caldera deformation, a significant finding was the three-dimensional imaging of a massive magma plume or pipe beneath Yellowstone that is responsible for carrying lava and extreme heat up through the Earth's mantle. In order to observe how seismic waves respond when they pass through various materials beneath the park, researchers at the University of Utah employed a vast network of seismic sensors in and around the area. They discovered a massive 3,600 cubic mile banana-shaped body that is about half a mile and deeper and contains partially molten rock using 3D seismic tomographic imagery. This is the so-called magma chamber of Yellowstone, an irregularly skewed plume of magma that feeds the shallower magma system, coming up through the Earth's upper mantle from the northwest and dropping 400 miles below, is even deeper and more significant in plate tectonic theory. This significant new finding disproves past claims that Yellowstone does not have a plume and is based on fresh seismic data. Another peculiarity is that the 3D image reveals that the plume does not start 1,700 miles away from the Yellowstone National Park beneath the Montana-Idaho border, but rather 125 miles away from an important upper mantle transition zone. However, Norris Geyser Basin, which has thermal features that date back 115,000 years, is Yellowstone's oldest thermal area. It is also the hottest, with a temperature of 459 degrees Fahrenheit, around 1,000 feet below the surface. The Steamboat Geyser in the area is an example of how quickly and unpredictably this scorching section of Yellowstone may shift. The 400-foot-tall geyser has rarely erupted in the past, with intervals between significant eruptions spanning anything from 4 days to 50 years. However, since March of last year, Steamboat has erupted up to once per week. The geyser erupted 32 times in 2018, setting a record that was surpassed the following year when it erupted 48 times. Helen Robinson, a geothermal expert at Glasgow University who is not involved with the new research, exclaims, "The blinking thing went nuts." Although this mercurial geyser's hyperactivity has drawn the attention of the general public, scientists are more intrigued by the dramatic quivering of the basin itself. The Norris Geyser Basin is a dynamic place. An 18-mile-long region climbed 4.7 inches between 1996 and 2004, then fell back to 2.8 inches between 2005 and 2013. Then, in late 2013 and early 2014, the area abruptly began to rise once more at a rate of 5.9 inches per year, the highest rate of uplift ever recorded within Yellowstone National Park. A magnitude 4.9 earthquake that shook Norris Geyser Basin in March 2014 abruptly stopped the upward movement that had appeared to be unstoppable. Up until the start of 2019, the ground gradually alternated between sinking and rising. The basin has moved so much that it's now 5 inches higher than it was 20 years ago. But what, therefore, is the cause of all this chaos? Significant changes have been found in Yellowstone's extensive underground volcanic system as a result of increased scientific surveillance. The system is centered on a massive caldera that is known for its geologically rare yet huge volcanic eruptions. The Yellowstone Volcanic Observatory was established here in 2001 to improve scientists' capacity to monitor and react to changes in Yellowstone's activity. The U.S. Geological Survey, National Park Service, Universities of Utah and Wyoming, University Navstar Consortium, and the State Geological Surveys of Wyoming, Montana, and Idaho joined forces to form the Yellowstone Volcano Observatory. The observatory is an extended, instrument-based monitoring program created to track earthquake and volcanic activity in the vicinity of Yellowstone National Park. Geologists believe that the Norris Geyser Basin upheaval began between 1996 and 2001, when magma rose just short of 9 miles beneath the surface. Radar and GPS data from satellites were used to track the deformation of the basin. The basin is situated on a network of faults and vents known as the Norris Mammoth Corridor, just outside the youngest caldera of the supervolcano's northwest rim. 2 weak zones crossing one another would be a location where magma would find it simpler to enter, according to derision. The magmatic intrusion caused the uplift event from 1996 to 2004, and as the magma cooled, dissolved fluids could bubble out of it. This procedure reduced the magma body's internal pressure, causing it to deflate like a leaky balloon. Between 2005 and 2013, the ground likely descended once more as a result of this process. Since then, the ground has been rising intermittently as a result of the escaping fluid becoming periodically trapped in pockets beneath layers of rock. For scientists, identifying and documenting this cycle of magmatism and hydrothermal activity has proven to be challenging. According to Poland, the new model is a reasonable hypothesis, but it's by no means certain. According to Robinson, it's possible that sources of fluids other than the magma body, including the recent heavy snowfall, concentrate in certain places and occasionally leak out elsewhere. The team surmises that magma-derived fluids are currently present in Norris Geyser Basin just below the surface. Thousands of years old hydrothermal explosion craters are widespread in the area. They are the result of geologic pressure cookers of confined, scorching water that violently depressurize and flash boil into steam if the rock cracks, an event that is nearly impossible to predict. Major explosions are rare, but Norris Geyser Basin could experience a fresh blast at any time. Explosions caused by hydrothermal processes may be a little more likely to happen if fluids have accumulated near the basin's surface. However, according to derision, the rocky plumbing networks are incredibly intricate, with minute, imperceptible changes constantly altering the likelihood of a blast. The team does not advise banning tourists from the area because the likelihood of further explosions is still quite remote. The team also questions whether the recent record-breaking number of eruptions in Steamboat could be related to the buildup of magmatic fluids. In the 1960s and the early 1980s, the geyser experienced comparable spikes in activity that may have been related to basin breathing cycles. If this is the case though, why does this specific geyser put on a show when others don't? Poland ponders, why not Aquinas, which is directly next to Steamboat? According to derision, the connection between the magma intrusion and Steamboat's hyperactivity is at best circumstantial, but the timing does line up. He and his colleagues intend to examine the fluids that bubble up through the surface in the future to determine if they bear the chemical signatures of a magmatic origin. Meanwhile, on the local night of August 31st this year, a 3.3 magnitude earthquake struck close to Lewis Lake in the southern region of Yellowstone National Park. So will the volcano in Yellowstone erupt once more? In the upcoming millennia or millions of years? Probably. What of the following several hundred years? How might a Yellowstone eruption appear then? Let's stress once more that there is extremely little chance of a Yellowstone eruption of any size. However, if we're speculating, a minor eruption in Yellowstone that results in lava flows and perhaps a normal volcanic explosion is the eruption scenario that is most likely to occur. As the magma rose to the surface, this would probably be caused by a cluster of earthquakes in a particular area of the park. Now, the warning indicators would be considerably more obvious in the improbable scenario of a much larger super-eruption. The entire park would certainly experience strong earthquake activity at first. Before an eruption, it might take those earthquakes weeks or months to fracture the rocks above the magma. What if we had a super-eruption which was 1,000 times more powerful than a typical volcanic eruption, spewed at least 240 miles of material, lasted weeks or months, and was characterized by prolonged activity? Within the park, The lava flows themselves would be restricted to a circumference of about 40 kilometers. In actuality, only about one-third of the material would enter the atmosphere. Volcanic ash, a mixture of shattered rock and glass, which would be thrown kilometers into the air and dispersed throughout the nation, would cause the majority of the damage. The Northern Rockies may theoretically be covered in 3 feet of ash by a super-eruption, which would obliterate major portions of Wyoming, Idaho, Colorado, Montana, and Utah. A few inches of ash would fall on the Midwest at the same time, and much less would fall on the coasts. The precise distribution would be based on the season and the weather. But any of those possibilities would be awful news. That much volcanic ash has the potential to destroy buildings as well as harm people, plants, and animals. Even a few inches of ash, which is what much of the nation is capable of receiving, can ruin farms, clog roads, lead to life-threatening respiratory issues, obstruct sewer systems, and even short out transformers. And most of North America would have to stop using airplanes. A large-scale volcanic eruption would also have a significant impact on the world's climate. Sulfur aerosols released by volcanoes can reflect sunlight back into the atmosphere, lowering temperatures. The impact is just momentary because these particles have a short atmospheric lifetime, yet they can still be very noticeable. When Pinatubo erupted in 1991, it temporarily lowered Earth's temperature by around 1 degree Celsius, 1.8 Fahrenheit, and a few regions may have experienced famines as a result of the Tambora eruption in 1815, which caused enough cooling to harm crops all over the world. And compared to what a supervolcano is in principle capable of, those eruptions were really little. There are currently no indicators of an impending eruption though. Although there are still earthquakes in Yellowstone Park and the ground is still rising and falling, this is nothing unusual. The likelihood that Yellowstone won't see an eruption for centuries to come is very high. The odds of Yellowstone exploding in any given year are 0.00014%, according to the USGS, which is lower than the likelihood of being struck by a civilization-destroying asteroid. Even so, it's not a reliable estimate because there's no guarantee that Yellowstone explodes on a predictable cycle or that another eruption is imminent. There may never be another significant eruption in Yellowstone. Super eruptions will occur on Earth in the future, but will Yellowstone experience any of them? That is not a given. Yellowstone has been around for a very long time. Perhaps not even a 4th eruption will occur. Indeed, volcanoes eventually fade out. The heat rising from below and the relative cold from the surface are 2 opposing forces acting on the magma chamber beneath Yellowstone. The chamber might theoretically freeze and finally transform into a solid granite body if the heat from below is reduced. Additionally, it's important to keep in mind that the volcanic hotspot beneath Yellowstone is progressively moving to the northeast, or more precisely, that the North American tectonic plate is moving southwest over the hotspot. If enough time passes, the hotspot will leave Yellowstone's foundation, and the supervolcano there will presumably cease to exist. In fact, a second supervolcano could form much farther to the northeast, but that wouldn't happen until the hotspot warmed up and melted the crust, and it can take 1 million years or longer for that to happen. It's difficult for us to comprehend something like 1 million years. The human species is a recent one. However, these systems take a very long time to operate, and Earth has been around for a very long period. Geologists have discovered evidence of at least 47 super-eruptions throughout Earth's history. Therefore, Yellowstone is not the only supervolcano in the world. The most recent took place about 26,000 years ago at Lake Taupo in New Zealand. More significantly, tectonic plate movement led to the enormous Toba eruption that occurred 74,000 years ago. According to others, that precipitated a 6 to 10 year global cold and may have all but wiped off the pre-human race. Although it's not an unbreakable rule, the Earth has typically experienced one super-eruption every 100,000 years. Since there is basically nothing we can do to stop Yellowstone from erupting, what can you do to protect yourself or increase your chances of survival? Much of that depends on how close is where you live to Yellowstone. Also, the immediate dangers happen during the explosion itself in the first few days. If you are close enough, you will face 2 major challenges: your roof caving in under the weight of the ash and killing you, or if you survive the destruction of your home, being without shelter and exposed and breathing in volcanic ash will do you in. The first thing is to ensure your roof does not collapse on you, although just how to do that is a big problem. Then you must ensure you do not breathe in the ash or let it get into your eyes. You may want to invest in industry-grade respiratory filters to filter out the harmful substances in the air that you will breathe when outdoors. You also need to wear military-grade eye protection goggles when you're outside, or simply stay indoors where your air is purified. Since the best plan is to stay indoors provided your abode does not collapse, you need to stock up on everything: food, water, fuel, electricity, drugs, and much more. You may be able to survive until you're rescued. However, the best survival plan is to evacuate the affected areas at the first warning. Meanwhile, even though a possible eruption is more intriguing and grabs the news headlines easily, there is another event that can make visitors to Yellowstone shake. Yes, literally shake, because many earthquakes happen in Yellowstone. In fact, in a typical year, Yellowstone National Park and its immediate environment witness between 1,000 and 3,000 earthquakes per year. So at least about 3 earthquakes shake Yellowstone every day on average, making the park one of the most seismically active areas in the US. Many of the earthquakes at Yellowstone come from regional faults caused by crustal stretching and mountain building. For example, major faults along the Teton, Madison, and Gallatin ranges pass through the park and likely existed long before the beginning of volcanism there. Any movements along these faults can cause significant earthquakes. The last major earthquake in Yellowstone's recent history occurred near Hebgen Lake, which is just west of the park. It was a 7.5 magnitude earthquake and caused damages equivalent to $70 million. And it didn't just cause property damage, as it killed 28 people. Most of the casualties resulted from a landslide triggered by the quake. Meanwhile, if you keep to the Yellowstone caldera, you would likely be safe from large earthquakes like the Hebgen Lake event. This is because geologists discovered they are unlikely to occur within the Yellowstone caldera itself. The subsurface temperatures there are high, and this weakens the bedrock and makes it less able to rupture. But that doesn't mean you are completely safe, because quakes within the caldera can be as large as magnitude 6.5. What is more, Yellowstone is vulnerable to even distant earthquakes. For example, in 2002, the magnitude 7.9 Denali Fault earthquake that struck central Alaska, 1,900 miles or 3,100 kilometers northwest of Yellowstone, touched the active Yellowstone volcanic and hydrothermal system and triggered hundreds of small earthquakes there. The region's hydrothermal system is highly sensitive to quakes and undergoes significant changes in their wake. Earthquakes may have the potential to cause Yellowstone's hot water system to destabilize and produce explosive hydrothermal eruptions. Yellowstone celebrated its 150th year of being open, but it was on a sad note. The park opened the high season with historic flooding that caused damage. Sadly, scientists warn the park management should brace for more flooding like this in the future. So what is going on in Yellowstone with flooding? In the second week of June 2022, an atmospheric river, which is a narrow band of tropical moisture, soaked the Pacific Northwest before dumping several inches of rain on northern Wyoming and southern Montana. This led to the closure of the park, and more than 10,000 visitors had to be evacuated. Many cars were stranded, campsites were flooded, roads washed out, and rocks were blocking the way. The management of Yellowstone was grateful for the cool, wet spring earlier that brought much-needed water to the region. The area had been experiencing drought conditions, so the water was welcome. However, things began to change in April and started raising alarm bells, as higher than median precipitation in the Yellowstone Basin helped build up the snowpack on the ground, which had increased to nearly the 30-year median by May. Between June 10th and 13th, the Absaroka and Beartooth ranges received between 0.8 and 5 inches of rain, which combined with 2 to nearly 5 inches of snowmelt. The combination of rain and snowmelt, amounting to 4 to 9 inches or 10 to 22 centimeters of rain, flowed over already damp soils which were unable to soak the water. The runoff deluged the Yellowstone, Stillwater, and Clarks Fork rivers and their tributaries. The Yellowstone River reached a maximum depth of 13.88 feet on June 13, 2022, which broke the previous record of 11.5 feet set in 1918. The river discharged a record 51,400 cubic feet per second of water on the same day, significantly more than the previous record discharge of 32,200 cubic feet per second attained in 1996. The rising floodwaters completely cut off large sections of the park by washing out roads and bridges. It swept away multiple houses and flooded hundreds more. Rock Creek also destroyed several bridges and flooded businesses in the downtown of Red Lodge, Montana. Residents of several towns were hit with power outages and polluted drinking water supplies due to the flood. While the establishment of the park took place 150 years ago, how long have people been inhabiting the park? The answer, according to scientists, is at least 11,000 years. In fact, the park has several names given to it by the different tribes that have lived there. For example, the Crow referred to it as the land of the burning ground or land of vapors, while it was many smoke to the Blackfeet people. The Flatheads tribe know it as smoke from the ground, while the Kiowa called it the place of hot water. However, more than just people from these tribes have made a living off the park in the past in its long history of habitation. In fact, if you hike along some of the modern trails, you are simply following in the footsteps of the indigenous tribes that created the corridors dating all the way back to 12,000 years ago, at the end of the last ice age when humans first appeared in the archaeological record in North America. Yellowstone attracted commerce thanks to its natural resources. It was the source of an important trade item in ancient times, obsidian. If you are wondering what obsidian is, it is an amorphous volcanic glass, a product of rapid quenching of magma upon eruption onto the surface. This item might not mean much to you today, but it was a prized commodity because it was used in creating arrowheads and spear tips. There is evidence that for over 11,000 years, the Obsidian Cliff, located in the Norris Mammoth Corridor just north of Roaring Mountain, was a buzzing crossroads of commerce for indigenous people. This resource drew nearby tribes into the boundaries of Yellowstone, and modern archaeological efforts have documented over 50 quarry sites on Obsidian Cliff. To date, obsidian quarried and napped from Obsidian Cliff has been found as far east as Wisconsin, Michigan, Ohio, and Ontario. Some evidence even suggests that certain tribes, such as the Hopewell people, trekked 2,000 miles from their home along the Scioto River in Ohio just to mine the prized obsidian in Yellowstone. But why are indigenous people no longer found throughout Yellowstone? Even though the US government agreed that the Yellowstone region belonged to the various local indigenous tribes, the establishment of Yellowstone National Park in 1872 more or less signaled the end of indigenous occupation within the park's boundaries. Park Superintendent Colonel P.W. Norris was determined to remove indigenous people from the newly established park because he felt they discouraged tourism. Rumors were spread that indigenous tribes feared the geysers and hot springs of Yellowstone. Many died of smallpox, and the remaining few eventually made their way to the Wind River Reservation, established southeast of the park. One of the most tragic events to happen in Yellowstone was captured on camera, but the park authorities won't let the footage be shared. If you've been to Yellowstone or seen pictures, you've probably admired the colorful hot springs that dot the park. However, one thing you should know about these waters is that you must never fall inside. A visitor, who we shall not name, learned this lesson too late and paid with his life. The man was visiting Yellowstone with his sister when he fell into a hot spring. Reports show the pair went to an unauthorized part of the park near the Norris Geyser. One of the chief deputy rangers suggested the siblings were looking for a place where they could soak in the water. The tragedy happened when the victim reached down to check the spring's temperature and slipped, ending up inside the water. When rescuers found his body, they could not retrieve it immediately because of a lightning storm. By the time they returned the next day, the body had disappeared, dissolved completely in the highly acidic water. There is acidic water in Yellowstone's geysers and springs because they come from deep underground, where they pick up sulfuric acid before reaching the surface. The sulfuric content is courtesy of microorganisms that break down hydrogen sulfide in rocks and soils. But how did the park authorities end up with footage of the tragedy? The victim's sister was recording on her cell phone when her brother fell into the pool. There are other ways to die in Yellowstone, including falling off a cliff and tubing the powerful Yellowstone River, where rafting is banned due to safety concerns. However, the vast majority of Yellowstone visitors make it back home safely, but it's important to pay attention to safety instructions in the park. But of course, Yellowstone is not the only place where volcanic eruptions with global impact can take place. For example, Krakatoa is still active and can still erupt again. The last time it erupted, the whole world felt it, but the people closest paid the highest price, which is why a warning system is crucial for the area surrounding Krakatoa. Krakatoa is located in Indonesia, and its last fiery explosion claimed the lives of more than 36,000 people, making it one of the deadliest volcanic eruptions in modern times. It all started with little warning signs like billowing smoke and small, seemingly insignificant earthquakes. These warnings were actually not ignored, but instead of fleeing, the people included the events in festival celebrations. In fact, the natives thought Krakatoa's natural fireworks were a mere lucky surprise, but that would prove to be a grave mistake. Shortly thereafter, the blast sent a cloud of debris 15 miles into the air. The eruption itself was so loud that it was heard some 2,800 miles away in Australia. It was also heard 3,000 miles away on the islands of Rodriguez, where it was described as the distant roar of heavy guns. It was loud enough to shatter the eardrums of people close by. The magma chamber ruptured and allowed seawater to come into contact with the burning hot lava. This created flashes of superheated steam that moved at over 60 miles per hour. The first set of victims stood no chance. The amount of ash and debris was so great that they cast darkness that didn't go away for 3 days. As the volcano collapsed into the sea, it generated a tsunami 37 meters high, tall enough to submerge a 6-story building. And as the wave raced along the shoreline of the Sunda Strait, it destroyed 300 towns and villages. The wave is said to have traveled around the globe 3.5 times at astonishing speed, causing tsunamis as far as South Africa and flinging huge chunks of coral reef onto the land as it went. Some of these sections of coral weighed as much as 600 tons. According to scientists, the Krakatoa eruption caused the oceans to cool for as much as a century. In fact, had the volcano not erupted, sea levels might be much higher than what we have today. 45 years later, Krakatoa was at it again. With sporadic eruptions underwater, some parts of the original volcano shot to the surface and formed an entirely new island, appropriately named Anak Krakatoa, or Child of Krakatoa. But Anak Krakatoa would lose part of its flanks in 2018 when Krakatoa erupted again. This small eruption caused another tsunami that killed 437 people, injured 32,000, and displaced more than 16,000 people. However, there is a type of volcano not included in the numbers above. It's an underwater volcano. You may not know about these underwater volcanoes because they usually happen far away, but that does not make them any less dangerous. In fact, most volcanic activities happen beneath the ocean. 2/3 of all volcanic activity occurs in the deep sea. So how does an underwater volcano form? Actually, there is no difference in the formation of submarine or underwater and subaerial or on-land volcanoes. Underwater volcanoes also form when molten rock is produced in the second layer of the Earth's interior and makes its way through the crust. As Tamsin Mather, a volcanologist and professor of earth sciences at the University of Oxford, puts it, most submarine volcanism is associated with a continuously active volcanism along mid-ocean ridges, where two tectonic plates are pulling apart. The collision of two plates can also cause a volcano. If both the tectonic plates are beneath the ocean, then the volcano will develop underwater, said Hilo. Over time, they may grow to form volcanic islands, he added. Volcanic activity within a single tectonic plate can also result in the formation of a volcano. This can happen when a hotspot is underneath an oceanic plate, creating a chain of volcanic islands like Hawaii. One of the notable volcanic eruptions is the Hunga Tonga Hunga Ha'apai volcano in the Kingdom of Tonga. In addition to sending ash tens of thousands of kilometers into space, the volcano also caused a horrific tsunami that killed 5 people and sent shockwaves across the world twice. This is a taste of what's to come. Due to its high activity and proximity to human areas, Mauna Loa, the largest volcano, has been consistently monitored over the centuries. Mauna Loa has been erupting for 700,000 years. It is one of the world's most active volcanoes, with the first recorded eruption in 1843 and the most recent in 1984. In 1930, the U.S. Geological Survey published a geologic map of the Hawaiian Islands that shows the many layers left by the eruptions of both Mauna Loa and the adjacent Kilauea volcano. There are 5 above-ground volcanoes on the island of Hawaii, but Mauna Loa is the world's largest, accounting for more than half of the island's surface area. The volcano has a surface mass of 5,271 square kilometers, 2,035 square miles, and a maximum breadth of about 120 kilometers, 75 miles. The vast majority of the volcano's huge structure is submerged. At 56,000 feet, 17,170 meters tall, Mauna Loa is nearly twice the height of Mount Everest as measured from the ocean floor's depressed crust to its highest point. Mauna Loa appears poised to erupt right in front of us, and its odds of erupting again are estimated to be about 100%, with possibly catastrophic consequences according to scientists. let's go back to underwater volcanoes because you are probably wondering what happens when a volcano erupts underwater. The impact of an underwater volcano eruption depends on its proximity to the water's surface. If the eruption happens at very great depths underwater, then the weight of the overlying water acts as a pressure cap. For example, if a piece of molten rock enters the sea 2 kilometers or 1.24 miles below the surface, it will come into contact with cold seawater and cool very quickly. The water will get very hot, but it won't turn into steam. The story is very different if the water is shallow enough. The magma starts to heat the water, which is then converted into steam, creating a big volume change. Steam explosions are really destructive because a small volume of water turns into a huge volume of steam. Aside from the risk of tsunamis, the massive ash ejected into the air when an underwater volcano erupts in shallow water can seriously impact people's health. The falling ash and emitted gases not only pollute the air, but can affect access to electricity and water supplies. Because they are underwater, submarine volcanoes are challenging to study. Due to their inherent inaccessibility, only a few active sites have been studied in detail. However, scientists working on land can learn about the history of a volcano by visiting the volcano sites and gathering data. This can be done using cliff sequences or digging holes and collecting materials. For underwater volcanoes, scientists usually have to rely on marine surveys and mapping technology like sonar. Even the threat of thermonuclear war or global warming would pale in comparison to an event like this, which would produce an ash cloud that would be capable of obscuring the sun. Millions of species would be wiped off over many years of freezing temperatures if this were to happen. While Mauna Loa is the world's largest active volcano, there are certain supervolcanoes that the world should hope to avoid. It turns out that the question with supervolcanoes isn't whether they could wipe out all life on the planet, it's a question of when it'll do it again. According to some scientific evidence, more than 95% of the world's plant and animal species may have been wiped out by an enormous supervolcano that erupted 250 million years ago. Yes, you heard that right. Around 200 million years ago, a supervolcano erupted with such force that it wiped out 75% of the planet's inhabitants. It was so massive that it split North America and Africa apart, forming the Atlantic Ocean in the process. The supervolcano Camp Central Atlantic Magmatic Province erupted over and over for 600,000 years. And there's bad news for those of us who live in areas where volcanoes aren't a problem. It wasn't that lava had covered everything in sight or that volcanic ash had rained down so heavily that everything was choked. Instead, it was the aftermath of the event's pollution. CO2 and carbon levels, for example, soared. The environment had been harmed. Only a few things managed to recover. It's worth noting that after the disaster, dinosaurs were able to evolve and take over before their own tragic end, demonstrating that no one wins for long. However, some rogue scientists believe that dinosaurs were wiped out 65 million years ago by a volcano, not an asteroid. There have been remarkable underwater volcanic eruptions, and we will dwell on their powerful impact next. Let's look at the most powerful underwater volcano ever recorded. In 2018, the largest active underwater eruption ever recorded birthed a giant skyscraper-sized underwater volcano. The insane thing about the eruption is that scientists are still making discoveries about it. What have they discovered? Scientists discovered the 2,690-foot or 820 meters tall volcano in the western Indian Ocean off Madagascar following a puzzling spate of earthquakes that struck near what is usually a seismically quiet area. After gathering geological data, including information from a 2019 underwater survey of the region, the team realized that there was a new submarine volcano about 1.5 times the height of New York's One World Trade Center. What's more, this new volcano draws from the deepest volcanic magma reservoir known to scientists. According to lead researcher Natalie Fouet, a marine geoscientist at the Paris Institute of Earth Physics (IPGP) at the University of Paris, the source of the magma, that is, the reservoir, is very deep, about 34 miles or 55 kilometers underground. It was the first time in volcanology that they could see such a deep reservoir at the base of the lithosphere, the outer shell of Earth that includes the upper mantle and crust. Between May 2018 and May 2021, more than 11,000 detectable earthquakes shook Mayotte, a small island and French territory between Madagascar and Mozambique. The most powerful earthquake was a magnitude 5.9, but there were also strange seismic hums or very low-frequency earthquakes that originated deep underground. They couldn't be felt at the surface, but they were picked up by seismometers around the world. These very low-frequency earthquakes are associated with volcanic activity. This sudden seismic activity was surprising, given that only 2 earthquakes have been detected near Mayotte since 1972, and until now, the most recent volcanic was left at least 4,000 years ago. In July 2018, scientists were stunned when they discovered that Mayotte was moving eastward at about 7.8 inches or 20 centimeters a year, as detected through GPS data. At that point in time, the island had only 3 or 4 GPS stations, so scientists installed global navigation satellite systems and ocean bottom seismometers around the island to learn more about the geological changes occurring there. The findings were extraordinary. The combined land and ocean bottom seismometers picked up 17,000 events between February and May 2019.
In any serious discussion of underwater volcanoes, you will hear about Tamu Massif. This water is the size of New Mexico or the British Isles. Tamu Massif is located under the Pacific Ocean, about 1,000 miles or 1,600 kilometers east of Japan. Tamu Massif is the biggest volcano on the planet and also competes for the biggest in the entire solar system. It is in the same league as Olympus Mons on Mars, which had been considered to be the largest volcano in the solar system. There used to be misconceptions about Tamu Massif, as scientists thought it was a composite of smaller structures, but now they have confirmed that the mighty volcano was just a giant volcano. Tamu Massif is a rounded dome that measures about 280 by 400 miles, or 450 by 650 kilometers, or more than 100,000 square miles. Its top lies about 6,500 feet, which is about 2,000 meters below the ocean surface. The base goes down to a depth of about 4 miles or 6.4 kilometers. Tamu Massif makes the largest active volcano on Earth, Mauna Loa in Hawaii, which measures about 2,000 square miles or 5,200 square kilometers, look like a child's toy. Made of basalt, Tamu Massif is the oldest and largest feature of an oceanic plateau called the Shatsky Rise in the northwestern Pacific Ocean. The total area of the rise is equivalent to the landmass of either Japan or California. The name Tamu Massif combines the institution the scientists came from and a French word. Tamu means Texas A&M University, while massif is French for massive and is a scientific term for a large mountain. So the scientists believe that Tamu Massif was created by a single volcano and probably over a short period of time. That actually took a few million years, but on the universe timescale where some events take billions of years, it's quite short. The volcano went extinct or inactive not long after it formed. That was probably in the late Jurassic to early Cretaceous period, about 145 million years ago. How did Tamu Massif form? It seems the spot on the seafloor had the right mix of elements, including a boundary of 3 tectonic plates, a thin crust, and a source of hot magma below that was able to bubble up to the surface. The molten rock poured out and then built up a wide, gradual rise as it cooled. However, just how the magma made it to the surface has not been established. Perhaps a blob of the rock got superheated and then rose to the surface due to buoyancy, or cracks in the overlying crust could have opened, allowing molten rock to spill out. And as massive and powerful as volcanic eruptions are, sometimes they go unnoticed, and scientists have to find clues after the fact to piece together what happened. This was the case that made scientists study a floating raft of pumice up to 5 meters thick that covered 400 square kilometers of ocean. Giant hunks of pumice the size of SUVs strewn across kilometers of the sea floor, a thick layer of sticky ash, and 14 lava flows. These are the clues that scientists hope will lead them to solve the mystery of the largest deep ocean volcanic eruption on record. We'll go back to 2012 when the Havre Seamount exploded with a volcanic eruption that was 1.5 times the size of the Mount Helens eruption in the United States. No one noticed anything about these outbursts from the Earth's crust until a few days later. That was when an airline passenger looked out the window as she flew over the Pacific Ocean. At 800 kilometers north of Auckland, she spotted an enormous floating raft of pumice and quickly took a photo, which she sent to a geologist. Unknown to this passenger, she had set in motion an international effort to solve the mystery of an underwater volcano. Later, in October of that year, the NIWA research vessel Tangaroa carried out a scan of the Havra volcano using an echo sounder. Creating a map from the data, scientists discovered that the map was quite different from how the seamount had looked when it was discovered in 2002. This actually confirmed other evidence suggesting that Havra was indeed the volcano that had erupted. 3 years later, a group of scientists headed to Havra intending to create a more detailed map of the volcano, taking photos and collecting rock samples. Of course, the evidence of the submarine eruptions these scientists were looking for is hidden beneath hundreds of meters of seawater. This made it very difficult to study, but an invention came to the rescue: underwater robots. The remote-operated vehicle, ROV, Jason, was connected to the research ship with a fiber optic cable, allowing the operators to see what the ROV was looking at as they drove it around. The underwater robot was also able to take photos and collect samples. The automated underwater vehicle AUV Sentry was pre-programmed to follow a set route as it took photos and measured water chemistry. By the end of the expedition, the team had generated a much more detailed digital map of the volcano. This map revealed numerous lava flows, a widespread ash layer, and millions of enormous pumice blocks, up to 9 meters across, scattered over the ocean floor. The robot also collected a number of large pieces of pumice. One of the things scientists tried to discover was the nature of the eruption. Volcanoes could be explosive or effusive. Explosive means, well, the volcano explodes, while effusive means that lava flows steadily form a vent. This is where the scientists found themselves at a crossroads, because the ash supports an explosive eruption, while the pumice and lava point to an effusive eruption. Speaking of volcanic eruptions, Huayna Putina is the site of the largest volcanic eruption ever recorded in South America. The explosion was so powerful that it sent mud flows down to the Pacific Ocean 75 miles or 120 kilometers away. Scientists even believe this eruption, which happened in 1600, affected the global climate because the summers following the eruption were some of the coldest in 500 years. Ash from the explosion deluged a 20 square mile, 50 square kilometer area to the mountains west, and you can still see the ash today. Although Huayna Putina in Peru is a lofty 16,000 feet, 4,850 meters, it's somewhat sneaky as volcanoes go. It stands along the edge of a deep canyon, and its peak doesn't have the dramatic silhouette often associated with volcanoes. The Huayna Putina volcano damaged 2 close cities of Arequipa and Moquegua, and it took a century for them to recover. The volcanic eruption of Krakatoa was more recent but no less deadly. It spent months giving warning rumblings before finally erupting on April 26th and 27th. The explosive eruption of this stratovolcano, situated along a volcanic island arc at the subduction zone of the Indo-Australian plate, shot out huge amounts of rock, ash, and pumice. The terrifying sound was heard thousands of miles away. The volcanic explosion also created a tsunami whose maximum wave heights reached 140 feet or 40 meters. The tsunami recorded a death toll of about 34,000 people. More than 7,000 miles away, the Arabian Peninsula recorded an increase in the wave heights of tidal gauges. The island that housed Krakatoa was completely destroyed in the eruption. However, new eruptions beginning in December 1927 built the Anak Krakatau, meaning child of Krakatau, cone in the center of the caldera produced by the 1883 eruption. Anak Krakatau randomly comes to life and builds a new island in the shadow of its parent. One of the largest eruptions in the 20th century was the Santa Maria in 1902. The violent explosion in Guatemala came after the volcano had remained silent for roughly 500 years. It created a large crater nearly a mile across on the mountain's southwest side. The symmetrical tree-covered volcano is part of a chain of stratovolcanoes that rises along Guatemala's Pacific coastal plain. It has experienced continuous activity since its last blast, a VEI-3, which occurred in 1922. In 1929, Santa Maria spewed forth a pyroclastic flow which claimed hundreds of lives and may have taken the lives of as many as 5,000 people. Another volcanic eruption that changed the world is the Thera eruption in Greece. Scientists believe that had Thera not erupted 3,500 years ago, the map of the world would have looked different. It is believed to be the single most powerful explosive event ever witnessed. There blew a large hole in the island of Santorini and sent the whole of the ancient Mediterranean on a different course. The eruption also had political effects. It completely destroyed the Minoan culture, which was the most dominant in the region at the time. While historians and archaeologists can't agree on the year Thera exploded, there have been suggestions ranging from 1645 BC to 1500 BC. But what is not in doubt is the evidence from ash deposits found in the ocean floor that Thera erupted with a force that humans have never witnessed. The picture would have been easier to piece together because no first-person account of the event exists, but researchers have been able to bench it against the Krakatoa volcanic eruption. Thera killed more than 40,000 people in just a few hours and generated colossal tsunamis 40 feet tall. It also sent volcanic ash across Asia, causing a drop in global temperatures. It even created strangely colored sunsets for 3 years. People heard the terrifying blast 3,000 miles away. Scientists say Thera's eruption was 4 or 5 times more powerful than Krakatoa. It exploded with the energy of several hundred atomic bombs in a fraction of a second. Meanwhile, scientists have not found human remains and valuables belonging to the Minoan residents of Santorini. This suggests they were able to predict the eruption and evacuate the island on time. Based on the nearby island of Crete, the powerful Minoan civilization declined suddenly soon after Thera's explosion. Tsunamis spawned by the eruption would have swamped its naval fleet and coastal villages first off, according to historians. The drop in temperatures caused by the massive amounts of sulfur dioxide spouted into the atmosphere must have also led to years of cold, wet summers in the region, ruining agricultural harvests. The lethal combination destroyed every notable Minoan stronghold in less than 50 years. This led to a free-for-all in the political vacuum created, leading to the warring city-state system of ancient Greece that would dominate the Mediterranean. The Aegean would turn out to be a fundamental building block for the history of Europe, and the Minoan decline changed its early foundation completely.